I was talking to Brother Balls about the record button or whatever,
Uh-huh.
and he looked at the Google Hangouts, and we were like trying to figure it out, and he couldn't find anyone either. So I think we do just do do this meeting, and then once we're done, then there's that link, and I saw Rachel when you posted it last time, it came up. I think that's just how it goes. So
I
we'll
tried
find.
to look at the video that you guys posted.
Yeah, how did
Um,
it go?
well, I couldn't hear any sound with it. And
Oh
like
shoot.
the sound was working for everything else on my computer. So I imagine that it was a problem with that.
Huh. Okay. I guess we'll just find out. This is like they can't deduct us from because it's the teacher doesn't even know how to do it, and so I'm sure that
Right, yeah.
we're making an effort and we're doing it, and so
Yeah.
I can't imagine that we're going to be deducted because
Yeah.
I don't know. I've really ever done this before, so oh well. Okay, so let's get into it. We'll start with lesson 6, yeah?
Yeah.
Okay. Let me just get my thing over here. Okay, so we want to do our the lesson 6 individual preparation that we had to cut out those squares.
Yeah.
There it is. Okay.
I just went to the website that it told us to.
Yeah, yeah.
But if you cut them out, then that's good, and we can do that.
Yeah, I did, and because I mean, having like a billion things up, I'm like, I don't know, I'm just going to cut the papers out.
Yeah.
I see you're on 2 screens. Okay, there you go. Okay. All right, so did anyone have any questions on part 1, though? I felt like that was pretty cut and dry. Does anyone need help with any of that?
No, I feel like both of these lessons were very clear and
Simple. Yeah.
really just repeated the same thing over and over
Yeah.
again.
Yeah, and it was even the notes, like even the text was super easy and fast. Like it
Yeah.
seemed like it was. I'm hoping that that's the way it's going to be the rest of the semester.
I hope so.
I will not like hold my breath, but I'm like, I think that would be so cool if we could just, not. I mean, I think the first couple of weeks, I bet they're probably a little bit more in depth because they're all new concepts, and so I'm assuming that it'd probably be just, something that we have to really, learn from
build that foundation.
the basis. Yeah, exactly, the foundation. Okay, so randomly select 5 of the 30 salaries to compute the mean. And so I got number 10 is 45,500. And number 20 is 37,900. Number 5 is 3,000. Wait, it must be 34,400. Number 30 is 45,200. And we need one more. And number 1 is 45,000 even.
45,000?
Yep, 45,000. Okay, so what is the mean of your sample?
41,600.
41,600?
Yeah.
Okay. Okay. Then this graph illustrates the sampling distribution of the sample mean. There are 142,506 possible combinations of the 30 salaries, drawn 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. Okay, so 41,600, and then 40.
A horizontal mark?
Yeah, okay, let's see that. Yeah, make a mark on the horizontal axis.
That makes more sense.
I know. How does that? Okay.
So like we would just put it, so the horizontal axis is where all of those numbers are, and we would just put a mark at 41.
Okay, so yes, so the it'll be perpendicular to the horizontal axis. Okay. I'm like, wait.
Right, yeah, I was like,
Okay.
horizontal, that doesn't make any sense.
Yeah, just a second here. Hold on, let me just get my brain going. Okay. 41.6. That's about right there, huh?
That's pretty far over to the left.
Yeah, that is. Okay. Okay. All right. So, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. The sample mean is just the way the whole distribution looks, right? The whole.
No, that would be the
Well,
sample distribution. The sample mean
okay.
is that specific value that we got.
This value. Okay, so it does seem
Unusual, yeah.
unusual to me because it's so extremely on that left side.
Yeah, I agree.
Okay. Okay. What was that, Rachel?
Making sure you can hear me. My internet's got a really bad connection, so I'm like cutting.
Oh, sorry. Okay. I can hear you, but it's
Really
quiet, kind of. Yeah. Do you have headphones that you can hook in with a microphone?
I can try. Let me try really quick. Hold on.
Okay. Yeah. Okay, so Jessica, what is this? Okay, the sample distribution is this bell curve thingy?
Yeah, it's the distribution of the mean of all of the means of like random.
And
When you
okay.
take random, I can't think of the word.
Simple random SRS, right?
Yeah, so when you just take a couple random values,
Yeah.
sort of like we did, then you take the mean of those and put them in a new distribution.
Okay, so that's the sample mean. Okay, I just want to get the terminology correct because when I'm saying it, it's like totally wrong.
Right. Yeah,
I like sound like an idiot, so thank you. Thank you for your help. I want to sound at least like I know what the heck I'm talking about, which I don't, but that's okay. I just got a text from Megan.
From what?
Oh, okay. Megan said, I can see you, but I can't get on. How do I get on the Hangouts instead of just watching? I don't know.
Have you been able to invite her to watch
Yeah.
it?
Yeah, I did. I invited her, and she said she can see us, but she can't
Participate.
participate. I don't understand why that would be.
Yeah.
Oh, she's just viewing it.
Right, yeah.
She has to, so it says one viewer, that must be her. She has to go in somewhere else to actually participate. There's another area, just a second.
Something that you have to do, because I clicked to show that I was viewing it, and then I
Yeah.
got like a little notification on my email.
Yeah, and I did. I sent all of you guys the same.
So maybe if she was to go back and look at that,
Yeah.
look at the email, and there should be like
Okay.
Hangouts pop up.
Okay, and then so if there's a link on there that she can just go to.
Yeah, like click
Okay.
the green spot.
Okay. Okay. Okay, just a second. I'm just texting you this real quick. Okay. Okay, so is that better, Rachel? Kind of?
My headphones won't work. I'm not sure why. I think it might be my headphone jack on my computer.
Okay. I can hear you better now.
Yeah,
A little bit.
better.
Okay. Okay, so let's do letter D. It says compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice? Oh, are we supposed to do it by ourselves? Okay. In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred. So I guess we do. Okay, so we can go back and
just do it a couple more times.
Select our types. Yeah, I'm going to just select my own, and then we can compare our numbers.
Okay. Have you guys gotten a mean
Yeah,
yet?
I got 45,920 is what I got.
I got 49,460.
49,460.
Mm-hmm.
Okay.
Say that
Okay, that was. What'd you get, Rachel?
It hasn't come up yet. Sorry, my internet.
Oh, okay.
Is slow.
Okay, and you know what? Honestly, if it's going sluggish, you can just kind of, because we got the first one that we got was 41,600, then Jessica's 49,460. So it's taken too sluggish. If it's too sluggish for you, then just listen what we're doing, and you'll get the picture. Okay, so yeah, that was a little bit more normal. I feel like that
Yeah,
distribution was a little bit.
Second one.
Yeah.
Normal.
Yeah.
And I think that kind of like illustrates the point of what it's showing is that eventually, when you do all of them, as many possible, like this says there's 142,506 possible combinations. As you do that many, it's going to create that curve.
Yeah, this curve, yeah. Okay. Okay, good. All right, so what do you notice? Yeah, you just said that. Okay, in practice, you only get to see, you do not get to, okay. Number 8, the Graduate Management Admission Test, GMAT, is used as an admission criterion in many master's and business administration programs. The scores on the GMAT are normally distributed with a mean of mu 529 and a standard deviation of 113. Consider a simple random sample or n equals 10 student taking the GMAT. What is the shape of the distribution of the sample means for all such samples? Okay. So this is lesson 6.
So this would be normally distributed because the original score distribution is normally distributed. So if it's a normal distribution, then it's also then the mean is
because it's
normally distributed.
Right, because it's the parent sample or whatever the main sample is the normal. Okay.
Yeah.
So the shape is just going to be like this one up here.
Yeah, it's going to be a bell curve. And we kind of answered B as well. How do you know that the distribution of the sample mean has...
Okay. Okay. Okay, now let's go on to the next thing, C. Okay, what is the mean of the sampling distribution of sample mean scores for all such samples?
So that would be 529.
529 because it's the same, right?
Yeah.
Same as the original one. Okay. Now, what is the standard deviation of the sampling distribution of the sample mean for scores? Oh wait, sample mean scores for all such samples. So, 113.
113 divided by the square root of 10.
Of 10, yes.
Oops, 35.73.
Okay.
Oh, that was so easy.
I know. That's what I felt like this lesson was. Like I get freaked out, like, oh my gosh, what's the question asking me? It's so simple that I'm like, wait, hold
I'm
on.
doing something wrong. That's how
Hold
I
on.
felt.
Okay. Yeah. Okay. All right. So we can go ahead and do the quiz.
Yeah, I feel good.
Okay. All right. All right. So see that Megan just texted me again and she said, I see your invitation, but no link. Did I do something wrong? Because I sent it to her just the same as I sent it to you guys.
So the invitation to view is different than the invitation to participate.
Okay.
But it
Okay.
looks
There's a plus.
added it as well.
There's a +1 right here. I'm just gonna add her real quick here.
Yeah.
Okay. 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 So she might pop on here, hopefully.
Yeah, hopefully.
Okay. Okay, so number 1, okay. All right. When using the when taking samples of n, what does that mean? N equals 5. Is that a typo or something? N equals 5. What was the shape of the distribution means histogram when the parent population is right skewed? So we know that is right skewed because if the parent population is the same as the sample means.
Well, yes, but also when it's skewed, so when it's not a normal distribution, it doesn't automatically follow the shape of the parent population. But in this case, it does because the sample size is small.
Okay. Okay, so that's the
So it's
indication.
going to still be right skewed or skewed.
Okay. And then so this one, when taking samples from n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? So this is a larger one, and it's normal because it's a larger sample, correct?
Yeah, because as it gets larger, it tends to be more normal.
Okay. Okay, when using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed?
It's just normal.
Yeah.
We don't even have to use the applet, right?
No, it's just because
it's
the parent population is normally distributed, so you don't even have to look at the applet.
Yeah.
It's just automatically like that. Okay. When taking samples of when n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? Again,
just normal.
The same, normal, because of the fact that it's n equals 100. It's a large sample, but that's just to put information in there to kind of confuse us, I think. Okay.
Yeah.
When would the distribution of means be normally distributed? Choose all correct responses. When data are drawn from a population that is normally distributed and the sample size is small.
That's true.
Okay. Data are drawn from a population that is normally distributed and the sample size is large.
That's
yes,
awesome.
Right? Okay. When data are drawn from a population that is right skewed and the sample size is small.
And that's not going to give
That's not true. Okay. And then data are drawn from a population that is right skewed and the sample size is large.
That is true.
That would be true. Okay. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean mu or x bar will follow the normal distribution. Okay. For bell-shaped data, approximately 68% of the data. Okay, we don't need. Has nothing. Okay.
No.
If the sample size is large, the sample mean x bar will be close to the population mean. And if the sample size is large, the shape of the sampling distribution of the sample mean x bar will be approximately normal.
That's it. That last one.
Yeah, I know. Just like Megan's calling me, but
Okay.
the central limit theorem has something to do with the shape. Okay, let me take this real quick.
Yeah.
Hey, are you not getting you can't get the link? Are you there?
No, yeah, I'm sorry. I'm looking at the bottom here where you see where it's added everybody.
Yeah.
And it looks like you added the wrong email.
Oh, did I? I just put +1 and let me redo. I'm going to type in your email exactly. So tell me what your email is right now over the phone. Okay, go ahead.
It's Dorothy Decker, but it's with a 15. It's Dorothy Decker 15 at gmail.com.
Okay, see DORO.
DHY.
Okay.
DUECKER.
15.
Yeah, at Gmail.
Okay.
I was wondering, like, I'm getting it on my Yahoo.
I see. I know. I can see that there's a viewer, and I'm like, well, we're popular. We got a viewer. Okay. Okay. All right.
It was working this morning for my other meeting, so I'm not sure why.
Okay. I'm sorry. It must have been that I just put that because I must have the 2 on there, and I think that first email that you gave us originally, I must have just had that on there, and so okay. I just invited you, so hopefully that'll take care of it.
Sorry.
That's okay. I know. I'm sorry. It's,
It has the quiz up though, so if you want me to tell you my answers.
we're actually on, for lesson 6, we're on number 9 of the quiz.
Like number 9, I got 10.
Okay. Okay, then you know what, if you want to, I'll just keep you on the phone, and then I'll talk to you and talk to the ladies. You won't be able to hear the other ladies that are on here, but at least I can relay. Yeah, okay. So, Jessica and Rachel, I'm just going to talk to her on the phone until I just I invited her with the correct email address. I think I had the old one on there, but until she gets on here, she's just going to we're just going to do this together.
Yep.
Okay, so let x be a random variable with population mean 10 and population standard deviation 6. Suppose the sample size of n equals 36 is drawn from this population. What is the mean of the distribution of the sample means? And
10.
she said, yeah, 10. It's the same, so 10. And that's what Megan said too. Is that how you pronounce your name? Is Megan, right?
Yeah.
Okay, so it is Megan. Okay, so number 10, what is the standard deviation of the distribution of sample means? So the standard deviation of the distribution of sample means?
I think it's 1.
Okay, I didn't calculate it yet, but I know it's 6 divided by the square root of 36, which, yeah, looks like that's 1.
I hate when it says
what you got?
3 decimal places and you're like, I don't know what to do.
I know, you get all confused. That's what they're just like tricky.
Yeah.
Okay, So regardless of the distribution, number 11, regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape distribution of the sample mean? So it would be normal if the sample size is large.
Yep.
Is that what everyone got? Okay. What theorem would justify response to question 11? And that is the central limit theorem?
Yeah.
Okay, because it usually what I get confused because the law of large numbers, is that the one that it will talk about the parent population, or what's an indication that we can take for sure that will be?
I think, I could be wrong, but I think that the law of large numbers applies more to probability, and so it states that like the more times that you do something, the more likely that it is that it will level out to the predicted outcome. So like the more times that you flip a coin, the closer it's going to get to actually being 50-50, rather than if you flip a coin 8 times and let's say that 5 of those times it's heads and 3 of those times it's tails. That's not quite 50-50, but if you do it more, then it becomes closer to that.
And so that's the law of large numbers?
Yeah.
Okay, that's helpful. Okay, and then I know the law of large numbers has to do with the spread of the distribution when it's large. Okay. Okay, so this one's good, and we can submit. Is everyone good with that?
Yeah.
Okay.
100%.
Yippity doo day. Okay, let's see here. Now let's go to lesson 7. Just while our computers are working here, so next Wednesday, it's the 4th, and we are going to have the teachers, the TA, come to our meeting. So we have to make sure whoever's in charge. I think Dorothy, or Megan, I think you're going to be in charge of it next time because we're rotating through. Is that fine with you? Yeah. Okay. And then we'll have to make sure we get the email for the TA so that we can invite her to come. Okay. All right. So let's see here. Mm-hmm. Why is that doing that? I don't know. She said it's just she doesn't have anything new with the email or the invite that I sent her. It's just setting her right back to the other page. So
that is really weird.
Yeah, I don't understand.
It should be a little notification that pops up in the bottom. Oh wait, here maybe is she going to the social part of her email?
Okay, Jessica asked if you were going to the social part of your email.
So there's like primary, social, promotions.
Because there's like primary, social, and promotions. So she's just in primary.
So go over to social. Okay,
go over to the social one. Oh, you can hear her. Can you hear her on the video there when you're? Yeah. Okay, she can hear you.
I don't have anything for today or today.
Really?
Why is that happening? Yeah, nothing today. Okay. I don't know. If you want, we can try to I don't know, play with it. Like if you want to invite me one time, and you know what I mean. Like we can try to play with it after we're done with it. I don't know. Okay. Yeah, just decide. I guess we'll have to. Maybe we can have to. I don't know. Okay. Okay, so mine printed up kind of funny, but on mine I see it says preparation assignment, and what number does the preparation assignment start with, guys?
Like for part 2, it starts with the number 4.
Yeah. Okay. Okay. I'm just gonna pull it up here. Okay. All right, so let's see, number 4. Let's see, samples of size n equals 4 taken from a normally distributed 2001 sales data. What is the shape of the distribution of X bar? So it's a normal shape.
Yep.
Okay. Sample size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X bar? The same.
Yep. That's
Okay.
normal.
A sample size of n equals 4 is taken from the normally distributed 2001 sales data. What is the probability that the observed X bar is less than 40?
So with that one, we have to find the z-score and then use the applet to figure
Okay.
that out.
Okay.
So we take 40 minus 45, so it would be -5 divided by the quantity of 10 divided by 4. Divided
The
by,
square root of 4, yeah. Okay.
so it would just be -1 is the z-score.
Yeah. Okay, -1, yeah. Z-score.
So then go into the applet,
Okay.
and it says less than 40.
Yeah. Yes, the X bar is less than 40.
So then it would be 0.1587.
0.1587.
Yeah.
Okay.
Does that make sense?
Yeah. Let's just plug it into that formula.
Mm-hmm.
Okay. Are you good with that, Rachel?
Yeah, that's
Okay. Do you have that, Megan? Okay. Okay. Number 7. A sample of size n equals 4 is taken from the normally distributed 2001 sales data. What is the probability that the observed X bar is greater than 35 and less than 55? So this is where we could use the same z-score, yeah?
Or no, because that z-score was for...
Oh, we have to do for 35 and then for 55. Okay.
But still for those same, like mean and stuff.
Yeah.
Yeah.
Okay.
Does one of us want to do for 35 and then someone else do for 55?
Sure.
I can go ahead and do 55.
Okay. Anyone want to do 35? I can.
So for 55, the z-score is 2.
Okay. And then for 35, the z-score is -2. So.
Okay, so then the area in between those is 0.9545.
Okay, 0.9545 area in between, yeah. Okay. Okay, number 8. Does anyone have any questions about that before we go on? Is everyone okay on that? Okay. A sample size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that X bar is greater than 41 and less than 49? Okay.
I'm looking at the key here, and
Yeah.
it's done exactly the same way. and the answers, just a couple different values, but the z-scores are -2 and 2 again. So it's going to be the same 0.9545.
Okay. Okay. So that's what we would have to do is calculate the z-scores for
each of them.
For 41. Okay. 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 All right. Okay, a sample. Are we okay to move on to number 9 then?
Yeah.
Okay. A sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed x bar is greater than 50?
So the z-score is still going to be -2, right?
What, say that again?
So the z-score is going to stay the same for this, right?
The same, no, it's different.
It's different because it has a different value. Let's see.
Yeah, because you're looking for a different value. You're looking for 50 instead of 49 or 41.
Right.
And it's asking for what's greater than 50?
Yeah.
Yeah. So the z-score is 2.5. Which
Okay.
makes the probability 0.0062.
Okay. Okay. Pair computing sold an average of mu equals 40 and p faunus, I don't know what that is, per minute in 2010 with a standard deviation of 12, and they looked at their p phone sales data and determined that the distribution is right skewed. Okay. So sample size n equals 4 are taken from the right skewed 2010 p phone sales data. What is the shape of the distribution of x bar?
So since the sample size is so small, I think it would just stay right skewed.
I'm sorry, do you guys hear my phone is doing something weird? Okay, it's... Why is it doing that? Do you hear that, Megan?
What was it?
I hear like this do-do-do-do-do thing on my phone. I don't know. Okay.
I don't know what happened.
Okay. Okay, I'm sorry, Jessica, I didn't hear what you said.
Oh, you're fine. The sample size, because the sample size is so
It's
small,
right
I think
skewed because it's so small. Yeah, exactly. Okay. Okay. So sample size n equals 40 are taken from the right skewed p phone sales data. What is the shape of the distribution of the x bar? So that one would be approximately normal because of the size of the sample, right?
Yep. So I think just like the general rule of thumb is if n is greater than 30.
Yeah.
That it's just approximate.
So if n is greater than 30. Okay, good. Okay, number 12. Is there a theorem that justifies your answer to question 11? Yeah. What is the name of the theorem? I don't know. Is there a name of that?
Yeah.
Law of large numbers?
That's the central limit theorem.
That's the central limit theorem? Okay.
Yeah. It says that as the numbers get larger, that the distribution becomes...
Oh, that's right. Okay.
Still talking about the shape. So the shape as always goes back to the central limit.
Okay. Okay. Sorry, I gotta make a note. Okay. All right, I got it on there already. Okay. Number 13. A sample size of n equals 4 is taken from the right skewed 2010 p phone sales data and you want to know the probability that the observed x bar is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why? So a sample size of n equals 4 is taken.
So that's a small sample size. And if it's small and right skewed, that would mean that it's not normal. And I think.
Yeah. And the applet is really only for normal distribution.
Yeah.
Because it is skewed, the value, whatever it is, would be equivalent to 0, pretty much. So it wouldn't make a difference.
Okay. Okay. All right. Number 14. A sample size n equals 36 is taken from the right skewed whatever. What is the probability that the observed x bar is greater than 36.5?
Okay. So we do 36.5 minus 40. And then divide that by 12 divided by
36.
6.
Oh, or square root of 36, sorry.
Yeah. So
Okay.
2. So the z-score is negative 1.75.
Okay. And then
You're supposed to find.
What is the probability that observed is greater than 36.5?
So then it's 0.9599.
Okay. Okay. Okay, a sample of size n equals 36 is taken from the right skewed, blah, blah, blah. What is the probability that the observed x bar is between 37.5 and 42.5? Okay. Yeah, I can do the 37.5 and someone else does the 42.5?
I actually just did the 37.5
Okay.
and it's negative 1.25. And I imagine that the other one is going to be positive.
Positive 1.25, yeah. Okay, and then
So
do you
it's
want to talk about?
0.7887.
Okay. Okay. All right. Should we go on to the quiz?
Yeah.
All right. So okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Example, if the answer is, okay. All right, so, all right.
So it said to the right. So greater
Okay.
than 1.358 and then less than negative 1.358?
Yes. And to the left. So they want the combined area under the standard normal curve. So we want to highlight to the right and to the left.
Okay, so it's going to be the two sides that are highlighted and not the middle. But the
Yes,
area,
that's correct.
okay, the area is 0.1745.
Yeah. And we want to round it to 3.
So 0.175.
Okay.
So
0.1745.
5.
Yeah, 175. Okay.
I thought, 0.175, I
Yeah,
think.
yeah, that's what we got. Okay. The United States, oh, number 4, is everyone ready for that?
Yeah.
Okay. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in this sample. Round your answers to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also the values that are as far away from the mean as ours in the positive direction. So we wanted, when we use the applet, we want to use the area on the right and on the left of the extreme.
Mm-hmm.
Okay.
So then the value that we use is the sample mean. So the sample mean minus the 185 pounds, right?
Okay, so I'm just going to write down what I'm doing is I'm going to write down, so the mean weight of passengers is, the first figure is 185 pounds, so I just put that. The previous value was lower, but was raised after a tragic boating accident. Okay. The standard deviation of passengers' weight is 26.7 pounds. So I wrote that down. So I got those 2 figures. The weights of a random sample is 48 pounds. Okay. So that is.
No, the weights of a random sample of 48 commercial boat passengers.
Oh, I'm sorry. I missed it.
The
Okay.
amount is the sample size.
Okay. So the number. So that's n equals 48, right?
Yes.
Okay. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. Okay, so I think a lot of those words in there are trying to confuse us, so I'm just going to use these 3 figures to, let me see, the sample mean was determined to be 177.6 pounds. Okay, so it's 177.6 minus 185.
Yeah.
And that's over 26.7 divided by the square root of 48, yeah?
Yeah. And the
Okay.
answer is negative 1.92017.
17. Okay, so we're going to round that to 3. So that's negative 1.920. That everyone gets that?
Yeah.
Okay.
But I don't know. Is that the answer that we're looking for? Or is it asking us to
Oh,
do
no. Yeah, that's the z-score. Okay, no. So that's
yeah.
the z-score, and what we want to do is we want to plug that into the applet to figure out the extremes. Let's see. Okay, so the question is, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed within the sample. Okay, so let's plug it
So
into the
we're
applet.
going to do the exact same thing as we did in number 3, where we're going to get just the sides.
Yes,
So it's going to
exactly.
be 0.055.
0.055. Okay. Okay. So We ready to move on to 5?
Yeah.
Okay. Which of the following, whoops, hold on, my computer is sluggish too, so when I scroll up, it goes crazy. Okay. Sorry. Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations is x, the distribution of sample mean is x bar, and this cannot be determined from the information given. So Megan, you said it's the first one?
The second one.
The second one?
Yeah, because the mean is going to have the smaller standard deviation.
Okay. All right. So that sounds good. Okay. Number 6, which of the following results implies that the spread in x bar decreases as the sample size increases? The normal distribution, the 68, 95, 99.7 rule, the central limit theorem, or the law of large numbers?
I'm going to the law of large numbers.
Yeah.
Law of large numbers? Okay. Yeah. Okay. The scores on the quantitative portion of the GRE are approximately normally distributed with a mean 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. Okay. All right, so Diane earned a score of 160 on the quantitative portion of the GRE. What is the score corresponding to Diane's score? Okay, so 160 minus the mean, 150.8, over 8.8.
So for the sample size, is it just 1?
Well, yeah, and that's what, yes, because when Brother Balls, when we were on our thing the other day, he said that if they don't give a sample size, you automatically assume that it's 1, so you just take the square root of 1 because it's,
Okay.
so you divide 8.8 by the square root of 1.
Okay.
So that's what, sometimes I get confused. I'm like, wait, hold on, this is too simple. Don't we need to add something more to this? But when he explained that to yesterday, I was like, oh, okay.
Yeah.
So, okay.
So the answer I got was 1.045.
Okay. Okay, 1.045. There we go. 1.045. Okay, number 8. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay, selected will score above. So the z-score is 1.045, and we can go ahead and just plug that in, yeah, to the applet.
Yeah.
Okay.
So I got 0.148.
Okay. Okay. Number 9, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? Okay. Okay. So we just take them and okay. Okay. Okay, so I got 1.045 again. Is that what everyone else got?
No.
For 9.
Yeah, number 9. What'd you guys get? So you added. Sorry, go ahead, Megan.
I got 2.34.
Okay,
That's
Megan
what
got
I
2.34.
2.338.
Okay, what did I do wrong? So a random sample of 5 students. Oh, 5 students. I got it wrong. Okay. For whatever reason, I had 8 divided by the square root of 1 again, but I should not have done that, right?
Right, yeah, it should have been 5 because the sample size
Okay.
5 this time. But you still initially found the mean of those 5 numbers.
Yes. Yeah, exactly. So,
So you did 160 minus 150.8.
yes. Yeah.
Okay.
Mm-hmm.
Yeah, so that last one was the only problem.
Okay.
So the answer is 2.338.
That's what I got.
Okay, 2.338. Okay. Okay. Okay, so what is the probability, number 10, are we okay to go on?
Yeah.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay, so we just plug that into the applet.
Yeah.
Okay. Okay, so what is the probability that the 5 is greater than the mean?
I got
Okay, so we want to make sure that we just highlight the portion that is on the right-hand side of the.
And it
Does
says
everyone
4
have that?
decimals this time.
Yeah, and it's the answer that I got here is 0.0097.
Yeah, that's what I got too.
Okay. Okay, so suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? And I would say this is approximately normal because of the sample size.
Yeah.
81. Okay.
I agree.
Megan agrees too. What is the number 12? What is the mean of the distribution of the sampling distribution for all possible sample sizes or samples of size 81 that could be drawn from the parent population? Round your answer to 1 decimal place. Okay. Oh, the mean of the distribution would be the same as what? Let's see. Is 3.5 students, right?
Oh, yeah. Yeah, you're right.
Okay.
Making it harder than.
I know, that's the thing is, like, sometimes I read these questions, I'm like, okay, now what formula do I have to start plugging stuff in? But anyway, so the reason why, Megan, on this, I'm sure you probably maybe already know this, but the mean is always the same as the original parent population in the original mean. Okay. Okay, so number 13, what is the standard deviation of the sampling distribution of the random variable x bar, the mean of the 81 students who are selected? It would be the same, wouldn't it?
No.
Standard deviation
No, it would
is
be
0.7
0.7 divided by 9.
divided by 9.
Yeah,
Oh, because it's the square root of this. Oh,
of 81.
I got 0.078.
okay. Megan got 0.078.
Yep. But it says to 1 decimal place. Oh, wait, no.
Oh,
No, for
okay.
this one is 3. You're right. 0.078.
Oh, that's right. Okay. Okay. And number 14, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay. Let's find the z-score on this one then, huh?
Yeah. So for the z-score, I got negative 2.571.
Okay, and I have a question. I just want to make sure I'm doing this right. Okay, so since the mean is the same, so we do 3.5 minus 3.5 over 0.7 divided by the square root of 81. Is that the
In
formula?
this problem, it's 3.3 minus 3.5.
Okay, where did you?
Because it says, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Oh, sorry. Okay. Oh, okay. I was looking at number 13 instead of number 14. Okay, thank you. I'm like, wait, where am I at here? Okay. Thank you.
I think we need to
Need to what?
I got negative 2.85.
That's what you got?
Yeah, but then that's our z-score. And then we need to put
That's
that in.
different than the z-score that I got.
Oh.
I got negative 2.57.
So we do 3.3 minus 3.5 divided by 0.7.
0.7 divided by 9.
Oh, okay.
Yeah, because of the square root. Yeah, because of this, it's square root 81. That's why we're doing this, ladies. That's why we're doing this. And I'm just confirming the calculation too. Okay. I got, well, hold on, negative 2.564. Is that what everyone got?
I got negative 2.571.
Okay, let me recalculate mine. Seven, 8. Okay, so I have negative 0.2 divided by 0.078, and I keep on getting negative 2.564. Should I draw mine? Maybe I need to draw. I wonder if the difference is, because I'm just rounding, like my bottom figure, my 0.7 divided by square root of 81. I'm just rounding that. So I have 0.078. Are you using the whole figure? It's like 0.07777.
Yeah. I was
That's
using
the difference then. Okay. I think that's what are you getting, Rachel?
Negative 2.571 is what I got.
That's what I got as well.
I'm going to put that down because I just rounded mine, which I think that's not a good idea. So
Don't we have to put that into the applet because it wants to know
number 14.
And it wants to know the probability that it will be less than 3.3, so wouldn't it just be whatever selected in the left portion?
Answer 14, or are we going to 14?
We're doing 14 right now. So yeah, we'll enter the negative 2.571 into the probability applet.
And then just everything on the left side of that.
So it's everything on the left side.
So it's 0.005 is or 0.0051 is what the area says, but we're supposed to round it to 3.
Okay. Okay, so number 14 is
confident with that.
0.005. Okay. Okay, that's what Megan got to.
Okay.
Okay, so the last one, number 15, it's what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? And so this is, we just do the same thing except for on the applet we highlight everything to the right. Is that correct?
Yeah.
Okay.
So I get 0.995.
Yep, same here.
Okay, everyone, Megan, everyone, you heard that, 0.995, is that what you get too?
Yeah.
Okay.
Yeah.
Yeah, okay. All right, and submit.
Yep.
This was a very
Nice.
nice group, I know. I'm so thankful that it didn't take over 2 hours this time. Okay, are there any other questions or anything we need to go over before we end?
I don't think so. I think everything was really clear.
Okay, everyone's good. All right.
Yep.
Thanks so much, guys.
Thanks. See ya.
Okay, bye-bye.